In this video, we're going to talk about how to calculate mean, variance, and standard deviation of a probability distribution. So here are some formulas. The expected value, basically what you can expect in the long run, and we're going to talk about what that means in the context of our applications that we're going to look at later. So the expected value basically is the same as the mean of the variable x. And the formula is the sum, this symbol right here, it's called the sum of all the products of the random variable x multiplied by its probability. Next, we have the variance formula, where we find the difference of each x value from the mean, and then square that difference, multiply by the corresponding probability, and then add all of such products up. Now, this is a formal formula. There is a shortcut to this formula, which I prefer and I use most often. My keypad doesn't work for some reason while I'm recording. So here's our shortcut formula. So instead of doing this, we could actually square each x value, multiply by the corresponding probability. See the I and I, so these should match. So if this is your first x, this is the probability of the first x, and then you're gonna add these products up, and then in the end you're gonna subtract the square of the mean that we found using this formula. So I'm gonna use actually this formula in our following examples. Now, and the standard deviation is, of course, a square root of the variance. So let's take a look how to apply those formulas. Here, we're told to find the mean and standard deviation of the given probability distribution. So the mean, or the expected value, is just the sum of the products. 0 times its probability plus 1 times its probability plus 2 times its probability plus 3 times its probability plus 4 times its probability. So when we add everything together, we're going to get 2.72. 2 points. So our mean is 2.72. Now let's take a find the standard deviation. So before we actually calculate the standard deviation, we're going to calculate the variance first. And in order to do that, we multiply each value of the square, each value of the variable first, and multiply by the probability, corresponding probability. And only after that, we're going to subtract a square of the mean. which is 1.6416. So now once we know the variance, we're gonna figure out the standard deviation by taking the square root of this value. And we're gonna get, so when we put it in the calculator, we get 0.281249, and we can round it to, let's round it to 3 decimals, 1.21. Okay, let's recall our rules for expected, unusual, and abnormal values. We're gonna say, well, if our expected value or the mean is given, and then the standard deviation is also given, and the standard deviation is given, that we can, then all the expected values are going to be within 2 standard deviations from the mean. Unusual values are more than 2 standard deviations of the mean, and the abnormal values are going to be more than 3 standard deviations away. So here's an example. Let's take a look. So we have given a discrete random variable such that the mean is 10, the standard deviation is 2. Determine the ranges for expected, unusual, and abnormal values. All right, so let's graph this situation. Mean is 10. So one standard deviation to the right is going to be 10 plus 2, so that's 12. And one standard deviation to the left is 10 minus 2, which is 8. Right? And then 2 more standard deviations, going to be 10 plus 2 times 2, so 4, and that's 14. And one more standard deviation to the left is 8 minus 2, or 10 minus 4, is 6. So this distance right here is within 2 standard deviations from the center. So we have 2 standard deviations to the left and the 2 standard deviations to the right. That concludes that interval includes our expected values. Right? So expected values are between 6 and 14. Now, the unusual values are beyond those points. By the way, we're gonna include those numbers, 6 and 14. Now, for the unusual, we have here, so all the values to the left of x, so the x is going to be less than 6, and also all the values to the right of 14, so x is greater than 14, and we're going to use our u symbol to basically unite both of those intervals into our solution set. Now, the abnormal values are more than 3 standard deviations away. So what is more than 3 standard deviations? So if we add one more standard deviation here, that's going to be 10 plus 2 times 3, or 3 times 2. That's going to be 16. So this point right here is 16, and abnormal values are going to be there. On this side, we're going to subtract one more standard deviation. So we could subtract 2 from this point, or 6 from the center, from the 10, because we know that this step is also 2, right? So this is 6 minus 2 is 4. So our abnormal values are to the left of 4. So here we're going to have x is less than 4, or x is greater than 16. And the last example in this video Let W be the number of heads out of 2 tosses of an unfair coin for which the tails are twice as likely as heads. Determine the ranges for expected, unusual, and abnormal values for the W. Let's just recall that we already figured out the probability table for this situation earlier. We need to figure out the mean and the standard deviation for this probability table. So this is what I got for the expected value. That's going to be 4/9 and 2/9. So that's going to be 6/9. 6/9, or if we simplify it, it's going to be 2/3. That's the expected value. And then the standard deviation, we're going to figure out the variance first. Don't subtract the square of the mean in the end. So what we get is 4/9 plus 4/9 plus minus 4/9. So we're getting 4/9. And the standard deviation will be square root of 4/9, which will give us 2/3. So for our unusual values and expected values, the mean is 2/3. The expected would be within 2 standard deviations, so that's going to be 2/3 plus 2 times 2/3, which will give us 4/3, so 6/3, which is going to be just 2. And then on this side, we're going to have 2/3 minus 2 times 2/3, and that's 4/3, and 2 minus 4/3, it's negative 2/3. So our usual values are gonna lie in this range. This is our usual values. Now let's stop here and talk a little bit about it, because we're talking about the distribution of variable W, which is the number of heads out of 2 tosses, right? So the average is going to be 2/3. So that means that 2 times out of 3, in the long run, if you continue flipping the coin, then 2 times out of 3 on average, you're going to have heads, right? Now, since the variable value W only takes on the positive value, this negative 2/3 doesn't have much sense in the context of the problem. So our usual values are going to be between 0, I would say, and 2. So it's normal if we are going to get 2 flips, 2 heads out of 3 tosses. That's usual, but anything more than that is going to be unusual. Now, the question is, if we get 3 heads out of 2 tosses, would that be abnormal or not? So let's find the abnormal boundary here. So that's going to be our mean, 2/3, plus 3 times standard deviation, which is 2/3 again. So what does that equal to? That's 6 out of 3, so that's 2. So it's 2/3 plus 2 is going to be actually 2 and 2/3. So not quite 3, yes. So anything more than 2 and 2/3, or approximately 2.6 on the average is going to be unusual. More than 2.6 heads and 3 tosses on average is going to be unusual or abnormal, actually. Abnormal. Okay, so that's how we interpret these results. And in the next video, we're going to look at more applications of the mean and standard deviation of the probability distribution.